In general, variables can be classified into two broad categories, and we can think of variables as data, and you will know why when I show you some examples later. So, there are three subcategories under categorical variables. We have the binary variables, we have the nominal variables, and we have the ordinal variables. And examples of binary variables include male, female, smoker, non-smoker, whether somebody is a scholarship recipient or not. These are all binary variables. And examples of nominal variables can include race or ethnicity, or race and ethnicity. Sometimes they come together, or hair color, or blood type. So, as you can see, for binary and nominal variables, all the categories are equal. There's no ranking involved in those categories. All racial ethnic groups are equal. All hair colors are equally beautiful, and all blood types, they are different, but they have different functions and characteristics. Unlike binary and nominal variables, there is ranking involved in ordinal variables. Examples of ordinal variables include level of education, from no education all the way to PhD, or professional credentials like CPA, JD, and so on and so forth, or the degree of satisfaction with a healthcare service, from very low to moderately low to somewhat high to very high, or the degree of preference for something, for a service, for a product, the degree of preference for, let's say, iPhone, from very low to very high. So as you can see, we can rank order the different categories for ordinal variables. There are some kind of ranking involved in the different levels of education and the degrees of satisfaction, or the different degrees of preference for a given product or service, or for the extent or agreement on something. They can be ranked from strongly disagree to strongly agree, with many categories in between. And there are two broad subcategories under the numerical variables. Numerical variables can be discrete, and counts are involved in discrete variables, like the number of children under 18 in a household. We can count them. And the number of marriages one had, we can count them. And the years of schooling. And as you can see from these three examples, there's no fraction involved. There's counting involved. We can count the number of kids, we can count marriages, but there's no such thing as half marriages, or a quarter of kids, or 3/4 years of schooling. Usually we don't operationalize these variables in fractions. And for continuous variables, they are characterized by measurements. There are ratios and decimals and fractions involved when we talk about continuous variables. Examples for continuous variables include BMI. And if you Google the body mass index, you can see the formula for BMI, whether they go by metric or non-metric. But there is some kind of formula for BMI that takes the height and weight into account. And because of that, they are fractions, percentages, decimal points involved in BMI. So because of that, BMI is one example of continuous but not discrete variables. Make sure you know the difference. And income, they are percentages involved. They are fractions, decimal points involved. So because of that, income falls under continuous but not discrete variables. If we just say annual income, monthly income after tax, and I'm sure you know, when you get your paychecks, your payslip, there are decimals involved in most instances. But sometimes we can rank income into different categories. We can say less than 10,000, 10,000 to 20,000, and 20,000 and 1 cent to 30,000, and so on and so forth. If we rank order income this way, then income is an example of ordinal variable. Make sure you know the difference. Sometimes the way we operationalize a given variable, they can fall under different categories. The same thing can be said for BMI. Certain numbers falls under the category of underweight. Certain numbers falls under the category of normal weight. Certain number ranges falls under the category of overweight, and certain number range falls under the category of obese. So if we categorize BMI this way, then BMI becomes an ordinal variable. And age, if we just say a person's age, sometimes age can involve decimal values. And because of that, age is an example of continuous variables. But sometimes we can also categorize age as 25 and under, 26 to 49, 50 to 64. When we do things this way, age becomes an example of an ordinal variable. Make sure you know the distinction. Okay, many times when you design a survey, when you write the survey questions, when you collect data on a group of people, we often assign numbers to represent different categories. And these numbers represented by categories can either be a categorical or discrete numerical variable. For instance, at my institution, a student can be either a Thomson Scholar or not. And when you collect data, we can assign the number 1 to the person who indicates that he or she is a Thomson Scholar. And we can assign the number 0 to the student who indicated that he or she is not a Thomson Scholar. And in this case, would it really matter if the numbers were assigned as 1 for Thomson Scholar and 0 for non-Thomson Scholar? Is the number 1 better than the number 0 in this case? If not, then Thomson Scholar is an example of a categorical variable. If being a Thompson scholar, being assigned a number 1 is better than not being a Thompson scholar and being assigned the number 0, then this variable becomes a discrete numerical variable. And the second example, visual functioning states. We can assign the number 1 to 5 for different visual performance. In this case, is the number 5 poor vision 5 times as bad as the number 1 having excellent vision? And the third example, healthcare satisfaction. We can assign the number 1 to very dissatisfied and the number 5 to very satisfied. And again, is the number 5 very satisfied 5 times better than the number 1? If the numbers matter, then these variables are example of discrete numerical variable.